Okay, so on this website, it's got the two basic principles of what we're talking about. We're talking about the counting principle today, and there's two different things. One is when you add the values together, the other is when you multiply the values together. Predominantly today, we're going to be dealing with the multiplication, okay, where one thing does depend on the other thing. If the things are dependent on each other, you would multiply the numbers together. If they are not dependent on each other, you just add the two choices together, okay? Which doesn't make a lot of sense to you just yet. But this first example is actually fairly good in here. So let me show you just the first example. So this is an example that we're going to talk about. In a class, there's 27 boys and 14 girls, and I want to choose one boy and I want to choose one girl. How many ways can I choose a boy and then a girl? Well, I take all the number of girls that are in the room, which is 14, and I'm going to pick one of them. That was 14 opportunities right there, right? Then I have the 27 fellas on the other side of the room. I'm going to pick one of them. So that was 27 opportunities. So 14 opportunities plus 27 opportunities made 41? Yeah, 41 different ways, 41 choices that were made. But did the boy's choice affect the girl's choice? No. Okay? So that's why those two are added together. Then we have more of what we're going to be dealing with today is more like this question number 2. So let's say you have 7 different flags, meaning, you ever see those signal flags?
Yeah.
Okay, that's kind of what they're talking about. Yeah, that's kind of what they're talking about. So you have 7 different flags of different colors. How many different signals can be created or generated if a signal requires the use of 2 flags, one that needs to be below the other? So here's 6 flags, each one of them different. I pick one, 7 flags. I pick one of them. How many are left now? 6. Because I took this one. So my first choice, I had 7 to choose from. I picked one. But that choice affected my next choice because I don't have 7 of them anymore. I now only have 6 of them. So this is an example of dependent. The first choice, I could pick anything I want. But on the second choice, that one flag is now missing, so I only have 6. So 7 choices on the first one times 6 choices on the second one makes a total of 42 possible combinations. So that's more of what we're dealing with today, okay? So that's just a little quick introduction of kind of where we're at. So here we go. Now, I'm going to show you how I like to do it with some things that are like this in your worksheet today. I would use this method a lot with your worksheet today. And we're going to do some more examples on the back. So don't think that this is going to be super, super short. All right, so let's say I have a dime and I have a quarter. How many coins do I actually have? I have 2 coins. So I have 1 coin, 1 coin. This is the dime, this is the quarter. How many now choices does each coin individually have? There are 2 choices on the dime. It could be a heads or tails. And there are two choices on the quarters. It could be heads or tails. If I multiply those together, how many total choices were there? Exactly. So there's 4 different combinations that I could choose from. So in this table down here, you could put there were 2 coins to start with times the 2 outcomes from each coin gives you a total of 4 possible outcomes in the end. Is that okay with everybody? Does that make sense? Okay. So what about this number 2? You get a choice of chicken, fish, or beef for the main dish, and then a choice of cake or pudding for dessert. So how many choices did you start with for the main course? 3 choices for the main course. And after that, you got to your choice of either one of the 2 desserts. So how many possible combinations could there have been? 6. Yeah, it's gonna increase a little bit, but that's the basic understanding. Yeah. Okay. Now we've got some clothing choices. We have a green or a blue shirt So that was colors, right? So there were 2 choices for your color. And then it says, on the shirt, and then it says you have blue, black, or khaki pants. So you had 3 choices for pants. Bless you. That's a total of 6 different outfits that you could create. Look at number 4. See if you can do that one. You've got pizza or spaghetti. So that's 2. You have milk or juice. So that's 2. And then you have pudding or an apple. 2 more. And if we multiply all of those together, we would have 8 different combinations of dinners that we could have. Are you doing okay with the idea so far? Okay, good. On number 5, we are going to do it like we've been doing it, but I'm also going to show you how to draw a tree diagram, because some of you who might be struggling a little bit, the tree diagrams can be helpful too. Okay, it's visually different. Some people like it. So a shirt comes in 3 sizes: small, medium, and large. So that's 3, right? Okay. Then it says each shirt will have either buttons or snaps to keep it closed. So that's 2. And the colors available are blue or beige. 2 again. So how many different wardrobe choices are there? 12. Good. Well, good. I'm glad you're smarter than you were in 3rd grade. That's awesome. You wouldn't say that. Okay. I would. Okay. So the choices for your school mascot are a lion, a bear, and a porpoise.
What is that?
What is a porpoise has been the most popular question today. It's like a cousin of the dolphin.
Yeah.
It's not a dolphin. No, not pink. No. They're essentially the same. There's just some genetic thing that's just a tiny bit different in a porpoise versus a dolphin. I don't remember exactly what it is, but it is something about their facial structure. But in general, they look like a dolphin. I think unless you're a professional.
I think it's in Finding Dory.
Is it? Okay, maybe. Okay. Huh?
No, there's none of those.
We need to ask Ms. Collins. She might know.
I'll ask her.
Ask her, okay? No, we're doing math right now. We don't have time for science. We're doing math. Okay, so, and they come in blue, red, or gold. Now remember, these are mascots, so these don't really come in blue, red, or gold. Okay, so 3. So a total of 9. Okay? Okay, good. Okay. Shh. All right. So that's how so each item that has, you write down each item, then you figure out how many choices each item has, and then you multiply all of that together. That's basically the idea, right? One more time. Let's build a tree diagram now based on question number 5. So that was the clothing with the shirts. They come in 3 sizes. So I'm going to move, I would encourage you, let's do it this way: small, medium, and large, and spread it out because you're going to need it. Okay? So shirts come in 3 sizes: small, medium, and large. After that, we know that each shirt that's there gets to have either snaps or buttons, right? So that means we're going to go, okay, the size small can have snaps or buttons. The size medium can also have snaps or buttons. And the size large also has snaps or buttons as a choice. Are you with me so far? Okay. Now, once we've gotten that part down, then it says we also have colors we get to choose from now: blue and beige. So that means the small shirt with the snaps comes in blue or beige. The small shirt with the buttons also comes in blue or beige. The same results would happen for the medium shirt. You would get blue or beige, blue or beige, as well as your large shirt, blue or beige, blue or beige. Okay? we're done with all of our choices. If you will now count all of the items at the bottom, you will find that there are 12 choices there. And that's exactly what we got when we multiplied all of our math together, okay? So that's just an alternative way to look at things. It does, but some people are very visual learners, and it helps them to kind of get their brain straight on what's happening. So as long as you show me you either multiplied the 3 times the 4 times the whatever, I'm good. Or you can draw a tree diagram. I don't really care. As long as you understand it, that's fine. What you can't do is just write down the answer, because why? I gave those to you. So you have to know how. Exactly.
I would just start at the S and B under all of them and then multiply it like each.
By 2 each. That you could do that. That's fine. I just wanted to give you one good full example of a tree diagram, okay? All right. On the back, there's a real quick little try it. Work it any way you want. You do not have to draw a tree diagram because it could take a long time.
What time do we get out of here?
At 39.
Oh, shoot.
Yeah, okay. That's okay, hon. All right, so answer this happy birthday to you event. You do not have to draw a tree diagram like it says. However, we are going to do some other examples that are going to be important for you to write down. So as soon as you get that done, we'll move on. Bless you. No, ma'am. No. You, pardon me? I just want one answer. Just tell me how many outcomes are there for these decisions. So show me your work and we'll be good. Yeah, and I have some, like I said, I'm not sure that, well, we'll talk about it in a minute. I feel that one question on your homework is not accurate, so I'm going to kind of punt on it a little bit because there have been multiple errors on this worksheet that I have found, so I don't know. All right, so how many different types of food will they have? They can choose from 4 different types of food. And then how many activities are there? 3 activities. And then what kind of gift? 2 gifts. So 4 times 3 is 12. 12 times 2 is 24. Okay?
That's all the work we have to show for that?
Yes, sir. Yes, sir. Okay? All right, now we're going to add about 3 problems to these notes. The 3 problems we're going to add are a little bit elevated in difficulty. And they're very similar to what your homework worksheet is. But you'll understand it by the time we get done, I promise, okay? So let's say we're talking about a car tag. Okay, so you need to write this down and not sit there. Okay? And let's say this car tag has 5 spaces for information. Or 5 types of data here. 1, 2, 3, 4, 5. Okay? Now, we're going to put some rules on this. I want the first 2 spaces to be letters. I want the next 3 spaces to be numbers. And there are no restrictions. What that means, restrictions. What that means is you can repeat the numbers, you can repeat the letters, there's nothing you have to worry about. Okay, so we have to do some thinking. If we're talking about letters, we're talking about letters in the alphabet, right? How many total letters are there? There's 26 choices. So letters, there are 26 choices to choose from.
10 numbers.
Okay, yep.
52.
And on the numbers, we can use 0 to 9 because it's only 1 digit per space, right? So on the numbers, we're going to use from 0 to 9. So how many numbers is that actually?
10.
That's actually 10 choices. Okay, so that's information that you need to kind of write down when you do these types of problems. So if there are no restrictions on my car tag right now, how many choices will there be for the first letter? No, for the first letter. There will be 26 letters in the alphabet. I can pick any one of those out of the 26.
Are there 25?
Nope, there's no restrictions.
26, my bad.
Okay, Things can be repeated, all right? So there's no restrictions. You can repeat them or whatever. So the second choice would also be 26, okay? The next 3 digits are going to be numbers. How many? And there's no restrictions. So we'll have 10 in the first spot, 10 in the second spot, and 10 in the third spot. What math will we need to do here? We need to multiply.
Cut off all the zeros and find out.
676.
No.
Let me see your calculator.
It is 676, but it's more than 676. Yes. 676,000. Okay.
676 000.
Yep. Over 500,000 different combinations of a car tag.
No wonder I never see the. Never mind.
They're not going to have the same numbers that you
I know.
And you're like, what?
I was like,
Yeah, it's crazy.
You
Yes.
have to make it really complicated. You have to put it over.
Okay. All right. Shh. Let's move on to the next one. We're keeping the same idea as far as it's still going to have 5 spaces in it. Okay. But now we're going to be grumpy. Now we're having no repeated values. Nothing can be repeated. No numbers can be repeated. No letters can be repeated. Okay. So I still want letters, letters, numbers, numbers, numbers. So my first choice of the letters would be how many?
26.
Okay.
Then 25.
But the second one is only 25 because I can't repeat it. You get it? Okay.
90.
The first choice is 10, but if I've used one, now there's only 9 to choose from, and now there's 8 to choose from. And what did you get, Cole?
4, 8, 6, 7, 20.
4, 8, 4, 6, 8.
0, 0, 0.
Yeah.
468,000.
Yep.
Oh, I got 4, 8, 6. It's close to
Well,
It's not hard to say big numbers.
All right. Are you comfortable with how you got those numbers?
Yeah.
Okay. Now, let's say we have a password.
Oh, no. Oh, those are.
Okay? Because they're always trying to hack into our stuff. So now let's make our own rules, hopefully, and have a password. Let's have it be 6 characters long. And how many do you want numbers and how many do you want letters?
5.
2 numbers.
No,
2
3
numbers?
and 3 numbers.
3 numbers, 4
No,
letters.
4. No, 4.
2 numbers, 4 letters.
all numbers, boys.
No, we got to do it like
Now, listen. We're going to be picky grumpy now. Okay? Let's say the first number cannot be. Ooh, okay. The first number cannot be
Fine.
odd.
So yeah.
So what numbers could it be?
You have
2, 4, 6, 8, and a 0.
Would you count 0 though?
Let's say it can't be odd or 0. That way we'll not worry about it. Okay? Okay.
4, 5. 4, 3.
Okay. So, how many choices for the first number if it can't be a 0 and it can't be odd?
4.
There's 4. How many choices can there be for the second one, though?
Is there restrictions?
No, wait, is it still? There's 10.
The only restriction we have is on the first one.
4.
So 10.
10.
Whoa, you're smart. Thanks.
The only restriction was the first space. We said the first space can't be an odd one or a 0. The second number, there were no limits.
You got me
Okay?
there.
All right.
26.
And let's say on the letters,
No vowels.
No consonant. No.
I don't know.
Make even someone.
how about we say
Will we include
the first letter has to be a W or a Z. It must be. Okay? So this first letter has to be a W or a Z.
Well, yeah.
So how many choices do we have?
2.
We only have 2 choices. Because we put some restrictions, some rules on it, right?
26.
After that, we weren't picky, were we? So we have 26.
25.
No, we didn't put any there. We can repeat it. 26 and
26.
okay. Somebody calculate that because I have no idea.
14060.
Cheater.
140
6080.
6080. No.
1,406,080,000.
$1,406,080.
Perfect. Okay. All right. The last example. Okay. The last example. Shh. Listen now. The last example is kind of unique, and I want you to be able to understand how to think outside the box a little bit. Because you might jump to a conclusion, and I want you to recognize, no, don't do that. Because I'm commonly known to do that. Okay? So I want to protect you from a bad mistake. So I'm going to give you a quiz. Okay? And there are going to be 4 questions. And each question has 4 answer choices. No. So, how many of you want to go, well, 4 times 4, we're good. 4 questions, 4 choices. I'm so proud of you.
That's what I said.
Good. You're way better than me.
It's like 4 to the 4th power.
Ugh. Okay. Somebody's going to rock this unit. All right. Finally. All right. Okay. So here we are, right? We've got 4 questions. Question 1, 2, 3, and 4. Notice I wrote them all out. And each of these questions has 4 choices. So 4, 4, 4, 4. So now when you multiply them together, you do get 4 raised to the 4th power, which is the same as 256, I think.
Yeah.
Okay. All right. Fantastic. So there's 256 different possible choices for answers. We good with this idea?
Yeah.
Okay. Y'all did really good today. That was fun. Wasn't it fun? It was fun when you participate. Good job. That's awesome. I had a good time too.
Is this our version?
No.